Good morning. I actually am as exhausted with my bio as you are. But I do want to say this is probably my intellectual home. And I say that to mean that I am a tester at heart. I think that my research program started out in human-machine interaction, and indeed for the first decade of my career, you'll see the bulk of my papers. But then, I have a lot of operational experience, and it started to deeply alarm me because I'm on the inside, right? I run around with Silicon Valley, and I started to see what people were selling. And this was pre-Gen AI, and it started to look like snake oil then. And now with Gen AI, if I'm not taking somebody to task on social media at least once a day for overclaiming the capabilities of Gen AI, I'm not happy, So, and in my academic role, I know it's hard. It's funny. I can't tell you who, but I have, and it's not Bram. But people in the DoD will they'll send me a link to a really egregious post that overclaiming something. And then they say, Missy, I know you'll say something about it. And I will, and I do. And so somehow I've become the secret complainer. Okay, I'm not sure why. All right, so you heard that I was, it's funny because I was at Duke, and the Biden administration approached me to help them with self-driving cars. And I had been doing some work, but actually the bulk of my research, I would say, is really in weapons systems, a lot of unmanned aerial systems. But because the sensor suite on robotic helicopters, for example, which is something I've worked a lot on, it's almost identical to that in self-driving cars, I was able to start, easily transition my research. So that's why I would say, the two major thrusts in my research are weapon systems and cars. And the funny thing is, between the two of them, the cars are far more dangerous. And we're going to hear about why today. So I want you to think of this as I'm a tech realist, which means that I believe in technology. I run a robotics lab. I'm here to make technology work in the future. But the reality is that AI has a lot of blind spots. And when I went into the Department of Transportation, I kind of knew that going in, but then after a little bit more than a year there, and I transitioned back to academia, I was on an IPA agreement. This is like the rent a professor agreement. And it took me a few months to sit back and kind of absorb it all. And then I came out with this article that really gave people the top 5 lessons learned. And so I'm going to skip through those pretty quickly. But remember, this is a cautionary tale. And while I know that, the Department of Defense is not exactly in transportation, you kind of are, though, right? You're transporting goods. It's a one-way on target, for example, but some planes have to come home. And indeed, you'll find that there are a lot of parallels to what you're doing. So the first lesson is that human errors in operation get replaced with human errors in coding. I just love it. And, anybody over 50, the only good thing about getting old is you do get smarter as you get older, and you really start to see the trends develop. And I find it hilarious that Silicon Valley thinks that they somehow can automate errors out of everything. And indeed, it's possible if you can get robotics right, or very tightly controlled automated systems, maybe, but humans are behind the development of the coding. And indeed, that's one of the things that we've seen over and over again in self-driving cars, are how human errors in coding get expressed at the worst possible times in operation, because these are latent errors. And I know all the testers in the community are like, oh, those are the worst, right? That's what we're trying to do in testing, is try to find them before they express themselves in operation. But let me show you how this happened in self-driving. This is too simple. It's a self-driving trucking company. It does no longer exist because of this accident. But the scenario here is the morning they had taken out a semi-tractor trailer and were testing it. Then they took a break and ate lunch, and then they take it out to test it in the afternoon. So The test driver you see on the left, my left, your right, is he's like, he gets the car set, or the truck set at 65 miles an hour on the interstate. He turns to the safety engineer and says, "Are we ready to engage the automation?" Thumbs up. And then the driver at 65 miles an hour hits autonomy engage, and the truck tries to do a 90-degree left-hand turn going 65 miles an hour on the interstate. So that's him fighting the steering wheel. The truck beneath it is just as the nose turns. So this person driving this white truck almost died. And it was just by the grace of God that did not happen in this way. They crash into the Jersey barrier. There's damage done, but no one's killed. Very fortunate. So what happened here? It turns out in what I call the CSI, crime scene investigation, because that's what I ended up turning into while I was with the government as a CSI person. It turns out that rookie mistake. The cache, basically, you can think about the buffer. When you type commands into your computer and something's hung up in the operations and you keep typing and then all of a sudden the commands get all pushed at one time. Basically, that's what happened. The drive-by-wire system is the actual translation of the AI into the system, and a bunch of the commands from the AI had built up in a queue from the morning's test. But rookie mistake, they forgot to dump the cache every time they went back to do a new test. Now look, there are those of us who have and those of us who will. If you're a robotics professor, inevitably somebody makes this mistake. Most of my students with drones, we have all lost drones because the students forgot to do this and the drones just took off on some set of last commands. But that's why we do this in college, so you make the mistake in college, not at 65 miles an hour on public roads. And this is where we start to see real problems emerge. So I would like to tell you that this company, Too Simple, was the only company that made this mistake. They're the only one I can name because this is the only public accident. But I sat on several investigations for companies that that where their engineers from Silicon Valley, some of which were, I don't know if they were directly my students, but they were working with my students, for example, where I didn't feel like I needed to go rescind some degrees. Because this is just inexcusable. It turned out there was a secondary factor. The laptop where the safety engineer looked at it, everything looked fine on the top layer, but having been an F-18 pilot, I know this exactly. If you drilled down several menus deep, you would have found out that there had been a software stale error code thrown. But you would have to drill, I lost several peer pilots for that same problem with a flight control error, and it took forever to find out that accident and several lives, right? So one of the other things I'm seeing is that the automotive industry is not learning the lessons that aviation learned really back in the 90s when we were transitioning from, analog to digital aircraft. And so, unfortunately, they're having to learn the hard way. Second lesson, failure modes can be surprising because AI is non-deterministic. And of course, this is indeed what most of you who are in the profession know. This is the long pole in the tent. What's funny about IDA is that about a little more than a decade ago, 2011, 2013, I actually did a IPA with ONR, and this is when I ran a robotic helicopter program. And so I worked a lot with IDA then, and I then was on your committee that you sponsored for AI testing. So these are like in the early days. And it's now, 10, 12 years later, and we still haven't made really virtually any progress on that testing. I mean, the questions we raised in 2011, 2012 are still the same questions about testing today. It's just really hard to get your arms around non-deterministic systems and how to find these potential problems. In this particular case, this is the Bay Bridge Tunnel, 2022, San Francisco, Thanksgiving Day. Tesla going 65 miles an hour in the tunnel, leading a pack of cars. The car sees something. It's a hallucination. You hear hallucinations a lot in generative AI. They are not hallucinations. They are statistical inferencing errors. Cars, self-driving cars, but really anywhere you find computer vision, which is potentially on a lot of military systems that I have worked on and am working on. Computer vision hallucinates for real. It sees something that is not there. We don't know how to test for this. We don't know how to identify it. And on this particular day, the car went from 65 to 0 in a couple of seconds, and then 8 other cars piled in behind him, because nobody was anticipating this. And this is something that I've seen over and over and over in my CSIs with the DOT, is that, this isn't just a Tesla problem. Tesla has a lot of computer vision. Cruise with their self-driving cars, Waymo, their self-driving cars. Any computer vision system has a problem with hallucinations. And the interesting thing about the military is you're going to be able to have more risk, right? That's what it means to be in the military. So I think that problem is a near showstopper for transportation like this, unless we can figure out how to do better data fusion. The military, you have a little bit more, it's a battlefield, so maybe hallucinations. And hallucinations in drones, for example, are not nearly as bad as what's happening here for cars, but it's still an open question. Lots of work to be done in that area. The third lesson is probabilistic estimates do not approximate judgment uncertainty. What do I mean by that? So a lot of the time in the world, you as a human, you are an autonomous system. You don't have perfect information about the world. The classic example is you're driving and then the ball rolls in the street in front of you. You detect the ball, but you don't detect anything else, but you instantly slow down because you recognize that there's a child, a sports, center nearby, and it could be even an adult who might pop out into the road to go retrieve that ball. So you have an imagination, you were able to connect that ball to a relatively rich projection about what is associated with that ball. That does not happen at all in self-driving cars. There is no thinking. And if there's one lesson that you learn from my talk today is AI knows nothing. There is no knowledge in a self-driving car. There is no knowing in generative AI. These are all just statistical predictions, and there's no knowledge, thinking, reasoning under uncertainty. And indeed, uncertainty is the real killer of these systems. So let me explain to you what happened in this accident. This is a cruise vehicle, San Francisco. You can see Geary Boulevard cutting across the screen. It's a big boulevard right in the middle of downtown San Francisco, very busy. This is at night. And the blue car coming from your right is an Uber. The yellow car that you see kind of orthogonal right in the center of the screen, it's under the red, this is the cruise car. It was coming opposite, and it's a busy boulevard, and it needs to shoot the gap. I have a 16-year-old right now in Fairfax learning to drive. Stay out of Fairfax. She's really terrible. Don't tell her that. But she's almost 17. And the reason why she hasn't gotten her license yet is because she's still really scary. Just stay out of Fairfax. She could not have done this. It's doable. Fighter pilots can do it. 16-year-olds probably shouldn't even try to attempt it. But so the car, though, has LiDAR, radar, it has all the sensors. So it actually has tracks on all the cars behind it, in front of it, going down the opposite. So it has perfect information, and it sees a gap. And it goes to shoot the gap just like that. But what's happening is the way they generate plans, it's constantly generating probabilities of what could happen next. So the blue car, it had been tracking at 40 miles an hour consistently. The car was not changing its speed from, a tenth of a mile before the intersection to 100 yards. It was constantly maintaining constant speed. And the car initially shot the gap, but then right as it turned, it recomputed everything. And the blue car, the Uber, is in a right turn lane only unless you're a taxi. So Ubers think they're taxis. So the Uber driver thinks it's legit that he's in this right turn lane only unless you're a taxi, so he's going to go straight. And indeed, I just told you he was going 40 miles an hour. And the car knew he was going 40 miles an hour. 40 miles an hour all the way into the intersection. What are the odds? I don't even have to show you the geometry. What are the odds that somebody enters a four-way intersection at 40 miles an hour is taking a right turn? Okay, right. I mean, you're all, maybe not everybody has a degree in physics here, but you all kind of do, because you're like, I drive and I know that if I went into a turn at 40 miles an hour in an intersection, I'm taking out everybody in the intersection and I'm not able to make that turn. You know, physics takes over, and I'm also probably going to run into a building on the other side of the road. The car somehow, for just the briefest of seconds, milliseconds, makes the estimate that it's going to take a right turn. But physics would dictate there's no way that's going to happen. But I'll have to tell you, this is the number one problem in Silicon Valley. They forget that they should include physics-based models. And all the old guard out there is like, young whippersnappers, they don't know anything about physics. That's how we make ourselves feel superior to them. They think they can code their way out of a paper bag, but you can't beat physics. And so the car, for just that brief of milliseconds, it says, I think it's going to turn right. It slams on its brakes. The car is 40 miles an hour into the intersection. It's impossible to avoid a collision. The car, it gets broadsided. There are two passengers in the back. Cruise, this happened about 6 months before their running over of pedestrian, which we're going to cover in a second. But 6 months prior to their big accident that caused them to lose their operational permit in California, they had this to say. Well, we had to choose between two different risk scenarios, and we chose the one with the least potential for a serious collision. I would tell you evidence suggests that you did it. This is where outcomes-based evidence probably rules on this one. So this was our first indication that maybe we had a cultural problem. And I raised this in front of you because there are a lot of Silicon Valley-esque companies that work for the Department of Defense. Look, I'm an advisor to Palantir. So I see what's happening on AI for the DoD way more than a lot of people inside the DoD see what's happening with AI. They're there to sell, they're set to sell products. And of course, I obviously think Palantir has a good product, but, are you asking the right questions, and are you sure that the companies that you're dealing with have the right culture that embraces the kind of testing? There have been a lot of fly-by-night companies. I was just bemoaning some company called Rebellion Defense that went belly up, that got a bunch of DoD money because supposedly they were going to be the next Palantir, and they didn't know what they were doing. And, so I think that one of the things you have to appreciate is that everyone here knows it. Even the big companies do it. The very first thing that gets cut is the testing budget when there's financial pressure, right? And the self-driving car companies think that the testing environment is their real, that's 100% true. Tesla does it, the self-driving car companies, we test while we're doing operations. And this is going to become something that, I'm not saying that that's never a good idea or never a problem, but in a lot of cases it is a problem. All right, the fourth lesson. Maintaining AI is critical. So this is something that most companies completely miss. The fact that AI requires maintenance. Just like that jet engine has to have, you've got to replenish oil, you've got to recalibrate whatever software is running it. You need to go do maintenance, not just once, not twice, but it's a continuous process. And the idea that you have to now have an AI maintenance division to go along with all the other divisions is just completely not obvious to most companies. And this is how this really manifested is this is another cruise accident. It sounds like I'm very anti-cruise, but just wait. We're going to bring Waymo to the table here in a few minutes. It's just that the Cruise and Waymo are the furthest ahead of most companies. And Tesla, which just, Tesla is not a self-driving car company, even though they might claim to be, they are a driving assist company. But in this accident, this was an accident that we thought was impossible. All the experts and pundits said, no way that this accident can happen. cruise vehicle hits the back of a bus. This was supposed to be impossible, especially if you have LiDAR, laser range finding, perfect information, down to centimeter level precision on LiDARs. Oh, wait, I forgot to tell you that LiDARs don't really, they have a problem in moisture after light rain, mist. But that's not the problem this day, right? Because it's a bright sunny day. You can see in the background. So this was actually the sweet spot for LiDARs. This could not happen if your LiDAR was functioning this day. So how is this possible that this accident happened? Well, in the CSI, we found out that this bus is an articulated bus with the accordion in the middle, the bendy bus. And the underlying algorithms, the computer vision system, had only ever been trained on traditional buses, single axis buses, no bendy in the middle. And what the system had done is it captured the front of the bus and knew that your typical bus was, let's say, 50 feet long. And it drew a line from the front of the bus to the end of the bus and then cut the bus off and then said there's only a bus in these 50 feet and no bus anywhere else. And because they had been having problems with false positives with the LiDAR, which happens quite a bit, one of the problems I had getting here this morning is there was a gigantic silver mylar balloon floating down at car level on Highway 1. It caused an unbelievable, people are slamming on their brakes like, what up with this mylar balloon, right? That would have been enough to cause a massive, massive traffic jam for self-driving cars because they don't understand that it's not a physically solid object. They just do detection, right? And because of that problem, they had dialed the LiDAR down to the secondary sensor in this system. So they said computer vision system, primary sensor, LiDAR only gets called if the computer vision system has any kind of uncertainty into it. Now, most of you have played around with Gen AI. The thing I love about Gen AI, my favorite thing this past week is that Gen AI said that Missy Cummings is an African American and invented self-driving cars in 2009. I mean, there's so many things to love about that. But it's very confident. I have given you this information, right? Have you ever let me help you with something else. I have given you the answer. So it turns out that it's quite confident that it made the right prediction, so it never called the LiDAR. And so the LiDAR had perfect information all the way into the point of collision. And the primary cause is the car companies never wanted to retrain the algorithms to include the bendy buses. And that's because it's extremely expensive to retrain neural nets in computer vision. So this is a huge problem. Companies are not incentivized. Indeed, they don't feel like they have to. Once they train their neural nets, and Cruise, to their credit, probably when they first were operating, this was fine. But then they started expanding their operational domain. We've all seen this, the requirement slide, right, where you start, and we call it the off-label use. You start using these systems in places where they weren't originally designed to use, and then you get these problems. All right, last lesson learned. It is clear that AI companies they're really scrambling. It's a hyper-competitive world in self-driving cars, and they really are just focused on the vehicle as a product. And they're not thinking about all the other systems level implications that go around operations. This is the crash that caused Cruise to lose its permit. So what you're seeing up on the screen is you're seeing the self-driving car. It had been going down the road, human-driven car, self-driving car, human-driven car just ahead of the self-driving car. A pedestrian jaywalks. It turns out that the car knew the entire time, saw it, saw the pedestrian self-driving car, because remember, it detects everything. Perfect information on the pedestrian, knew that the car was going to collide with the pedestrian, detected all this, had all the right vectors, did not slow down ever. No defensive maneuvers. Like if you saw a person being about to be hit by a car, you would start to slow down. Nope. They don't slow down at all. They go into it. The woman gets kind of hit obliquely, kind of rolls over the hood right into the path of the self-driving car. The accident cannot be prevented. Physics takes over. So the cruise now sees that this is going to happen, slams on its brakes, hits her, but not too hard, definitely survivable. Hits her, then decides to actually do a pullover maneuver and pull over to the side of the road. She's under the bumper, gets caught under the car rolls over her, and it's hard to see, but her feet are right under the back left tire. She's still in some kind of rehab right now. I mean, this was October of last year. So there's so many things to unpack here, but the most important one that I want to talk about today is it turns out they have a remote operations center, just like the military does. And there were people in Arizona, this is happening in California, who saw basically this whole thing unfold. At no point, they could hear her. They could hear her screaming under the car. They had no big red button to stop this. They, you can think about predator operations, they have the ability to affect change if they see something. But in this particular case, they couldn't do anything. They were subcontractors to crews, not actual employees. They kept trying to escalate their concerns, but it wasn't clear what that person could do because, again, there's no red button. There's no way for anybody in the remote operations center to literally intervene and stop something bad like this from happening. And so it just goes, it's a good lesson for other companies and for everyone else to say, look, if you're going to have remote operations running around, and they recognize that the autonomous operations, they recognized they needed remote operations for supervision, but then we call it safety theater. They didn't actually provide any mechanisms to make anything happen. So, that's bad. And at the same time, the city had been really suffering from a lot of problems of congestion. Cars, they would freeze in packs. Indeed, it happened again just a couple of days ago. But they freeze in packs inside the city of San Francisco, and they cause massive congestion across the whole city. They block first responders, firefighters, police officers, ambulances. People are not getting to the hospital in a timely fashion because they're being held back by all the self-driving cars that are bricking in place. So that led to, humans are so clever sometimes, humans figured out, they have a rebel group, they call them Safe Street Rebels, figured out that if they ran around and put orange cones on the hoods of cars, that would stop the cars in place. So it's some kind of passive resistance. And so all of this is unfolding. Pedestrians are getting run over, people are protesting, and they don't want the cars. You have to appreciate in San Francisco, it's not just Cruise and Waymo. Every car company, and there's probably at least 24, are testing their cars in San Francisco. It's like that's the, the big holy grail is if you can do it in San Francisco. So the people of San Francisco have had it. And this cone incident is a good example of just what the public thought. And then nobody did anything. The car companies just kept expanding, and people kept asking the city to stop. The city cannot ticket them. The city cannot do any financial penalties. There's no feedback loop of disincentivization to make the companies consider the public more. And why is that important? Because in February of this year, this happened. This is a Waymo. A Waymo car bricked at an intersection. It was Lunar New Year in San Francisco, and then people have fireworks in their pockets, and then the car misbehaved, and then it's just truly an amazing sight when you see what happened. But somebody had fireworks, decided to put the fireworks inside the car, that caught them, and it burned to the ground. I'm not advocating that this is a good idea, but you have to appreciate that this is where the level of public sentiment is for the cars in their city. And I think this is the one lesson that I think people should learn from this is if you don't develop autonomous technology with all the stakeholders in the system, all of the stakeholders in the system, and you start to have problems, which you inevitably will, then you need to appreciate you've got to start doing a better job of working with the stakeholders. I don't think the military, it's not like the military has to worry about somebody getting a hold of a drone, for example, and burning it to the ground in the civilian world, but you do operate in areas where you could imagine public sentiment is absolutely going to impact whether or not some of your technologies are tolerated. So last set of ideas is, because of all this, I ended up going back and saying, look, we need a new way to break down these accidents that are related to AI. And most of you are familiar with Reason's Swiss cheese model, which is a way to deconstruct accidents to look at root causes, whether it's organizational influences, unsafe supervision, preconditions for unsafe acts, and then the unsafe acts. And Jim Reason actually did this for pilots. There were so many aviation accidents. And, I was in the military. As soon as something bad happens, it's always the pilot's fault. And that's, it's only the pilot's fault. But then they started to realize, well, wait a minute. If a pilot hits it, the pilots always hit the back of the ramp at an aircraft carrier at 3 a.m. Why do we even do that? If we know that they're tired, and then maybe we were giving them speed, and maybe, there's all these reasons. And then when you back up, I'm like, okay, yeah, the pilot made a mistake crossing the ramp. But, we were pushing them physically. We weren't giving them crew rest. Leadership decided that we were going to use speed. This was a long time ago. So you can see where, yeah, it's a good idea. But the problem with this framework is that it has nothing to do with AI. And so it's really hard, like, okay, now it's the human who's doing the unsafe act. How could we use this to help us rethink what it means to have artificial intelligence? So I rethought it, and I'm now starting to publish this. More and more papers are coming out. But the idea is that you have also 4 layers, but they're 4 different layers. The first one's the same, inadequate AI oversight, right? If you're a company and you have given, and you've got all this negative feedback, it's inadequate AI oversight to make sure you're doing sufficient closed track testing before you take your semi-tractor trailer and put it on an interstate where it could really kill somebody when it goes wrong, right? Inadequate AI design. The Remote Operations Center has no way to intervene when something goes wrong. They need the big red button, right? There's an inadequate design feature. Inadequate AI maintenance. You're not retraining. When you're expanding your domain, you must retrain your algorithms to consider the new objects in that domain. And then last but not least, the one that this crowd really should care about is inadequate AI testing. It is abysmal in the self-driving world. It is also, I would say, I don't have insight into every single company, but I do see a lot of robotics research being proposed to the government. AI testing is never even in it. So we do research all the time for ONR, AFOSR, AFRL, you name it, ARL. And testing is just fundamentally not part of what is the research that's happening. And, it is great to have AI, and anyone can show you a demo where AI works great for that 10-second clip that they're getting. But to have it consistently work, if you haven't seen the Boston Dynamics clip of their Atlas robot and all the mistakes that it made, they released it yesterday because they're shutting that program down. But you would never have guessed that these mistakes were being made because of the videos they clipped to make them look wonderful, right? And so it is a big problem inside of the operationalizing of AI inside of companies. It's a big problem inside of academia. The National Science Foundation, for example, does not think that testing is a legitimate research area. I know, like a lot of people are like, oh, it's my third rail. I have complained enough that they're starting to listen and maybe have some proposals that are coming out that are focused on, you know, the testing and certification of systems. So hopefully we're turning the tide. But I have to tell you that I was part of the military for a long time. And I was there when I saw, you know, when the test ranges started to go away. And there's been a big push to replace testing with simulation. Some testing and simulation is good, especially in the early part of a project. But now what we're seeing with the rise of AI, we've actually never needed physical test facilities more than we do right now. And I think, and I have preached, I was on the Defense Innovation Board, you know, I'm on all these committees. We need to not get rid of our physical test facilities because of the non-deterministic nature of AI, we must start rethinking what it means to test systems in the real world. Indeed, especially with computer vision, real world testing is critical. It's critical for all. They're not doing enough of this in the systems that you see that I just talked about. The companies who are proposing projects, they want to tell you, and I hear this and I arm wrestle with people all the time over this. We can do everything in simulation. We can test everything in simulation. I am here to tell you that I have seen all these car companies say that they did all this testing, and of course, they never found any of these accidents, which were, you know, the odds of hitting a pedestrian that was already hit by another car. I mean, they're low, but they're not in the 0.0001 percentiles, right? They're in the low percentiles, but not the 0.0 percentiles, right? So I tell you that I'm on your side. I feel for you. Again, the companies, Boeing just continues to amaze with their inability to do good testing. I say this as the former Boeing professor at MIT. It makes me very sad. But it just goes to show you that it's not just a car company issue. It is all over that testing is never valued as much as the development of the vehicle. But with AI, and don't even get me started about Gen AI, we need more testing. It's got to be written into the contracts. And I know that you've probably heard, you know, we like DTOT. It's in the old world of the physical deterministic systems, maybe that was going to be okay, but these really need to start blending now because they're not two distinct gateways. It's actually, you know, a continuum of testing that needs to happen, not also just in the lead up to deployment, but then the constant, that AI maintenance, and how IDA now needs to have kind of, you know, you have to have your own quality assurance division, right, to continue to manage this. So I know I've laid out a lot. I was going to have time for questions, but clearly, and now I'm up against the break. So I'll take questions, you know, after the break is over. But I really appreciate your time here, and I really appreciate what you're doing. No one appreciates your mission probably more than I do. Thank you.